this video, we're going to study the concept of clusters. We're going to review some of the optimization buttons in MPTF and also simulate a composite data set from the fitted model to a composite data set. So we want to look at, we're going to be looking at multiple segments. So if you go to the tree structure in your database, click on the plus next to the variable multiple, and then select segments, you'll see that there's a composite called SEGX10, which is really the composite of SEG1 up to SEG1, SEG9, all the way up to SEG10. So let's open SEGX10, and when you open it, there's a composite data set. If you got a composite data set, it's made up of the incremental triangle, paid loss triangle for each one of these segments, SEG1 to SEG10. There's also some simulated triangles. Well, let's not worry about those. We're going to do our own simulation. Let's go back to triangle groups. That's the triangle groups tab. These are the triangle groups contained within the composite triangle group. Back to models. There aren't any composite models. That's empty. So you've got the models button active, the composite active. Let's go to related. And the way you always start off in MPTF is you might have saved each one of your optimal models as, say, good in PTF. So you highlight good. I mean, this has already been done for you. We're not really sort of looking here at, you know, what is an optimal model in PTF. We already assume that we have it and how to proceed from there. So I highlight all these with the control, with the right button of your mouse, shortcut context sensitive menu, click on open. And now say tile vertically, minimize regression table, so you'll just have the model display and the residual graphs. If you look at the model displays, but each segment seems to have the same structure. I actually simulated this. I simulated this composite data set. But you'll find out later that typically layers and also net of insurance versus gross, segments, medical versus indemnity, very often have very similar trend structure. Okay, now when we ran these models, the system also calculated the correlations. This was the process correlation and the residuals. So let's go to the OC button, optimize, optimization of residual correlations, this button here, O sub C, open it. And these are all the correlations. I'm going to maximize this window. So we've calculated the correlations and the residuals between any two pair of segments. So there's all the correlations there. And, you know, the more data sets you have, the more correlations you need to calculate, but you're also calculating parameters, parameter structure, trend structure for each triangle. So that's really a lot of parameters. I mean, you need to think of calculating correlations as calculating another parameter. So now the system allows you to create what we call clusters. Typically, two segments or two lines of business or two data sets will belong to the same cluster if the process correlation is in fact significant. Though in different clusters, if in fact the process correlation between these two members in different clusters is insignificant. And the way to set up clusters, there's a number of ways. First of all, I usually treat negative correlations as insignificant, because if the negative correlation was significant, you'd get much more sort of risk-credit diversification than if the correlation was zero. Now, one way to create clusters is retain all significant correlations. And in retaining all significant correlations, let's click on that. You're going to also retain some correlations that are insignificant. Now, when you remove all insignificant correlations, you'll also remove some correlations that are in fact significant. So over here we have removed all insignificant, retain all significant correlations, and the system is set up automatically 1, 2, 3, 4 clusters. If you don't like these clusters, you can always change them manually. For instance, let's suppose to cluster number 1, the selected line is this line here. You want to add seg3 to that cluster. In other words, you want segment 3 to belong to cluster 1. All you need to do is click on here, double click on add to selection. The action is add to selection. Let's double click. So now seg3 goes in with the other ones. If you want to remove seg3, let's remove it. Okay, then it goes on to its own cluster. Okay, it goes on. If you now want to add seg3 to seg4, say, so what you could do is you make the selected line number 3, this cluster here, seg4 number 3. So that becomes a selected line, and then you add to selection, so you would add it seg3 to the selected line, which is seg4. Let's do that. So you put it back in there. Okay, so you can change things manually. Just to make sure that we're back where we were, let's now say use estimated correlations. On the left here, let's click on use estimated correlations. Okay, and now go back to retain all significant correlations. So we're back there. Now, if you're going to remove all insignificant correlations, then you'll have to remove the blue. Now, would it make sense to remove segments? Segment 6 is not correlated to segment 2, okay? And segment 2 is not, okay, so do we remove, okay, segment 6 and segment 2, let me rephrase that, are not correlated significantly. Now, from the cluster, would we remove segment 2 or segment 6? From this cluster that contains seg1, seg2, seg... Which one do we actually remove? Well, let's see. The correlation between segment 2 and segment 1 is 0.19. Segment 6 and segment 1 is higher at 0.38. Just look at this line here. It's 0.38. So if you're going to remove one of segment 2 or segment 6, makes sense to remove segment 2. Let's see if it does that. Remove all insignificant correlations. It should remove segment 2. It has. And it's put it on its own, as its own cluster. So typically what I usually do is I remove all insignificant correlations, but this will mean also that you might remove a significant correlation. So this is basically the clusters that have been set up by the system. And now all correlations are in fact significant. Notice that the correlations that are insignificant are kind of grayed out, okay? But if you estimate at the bottom left here, if you now estimate the same model, the same trend structure, but use these process correlations, click on estimate, those correlations, when insignificant, all become 0. In fact, that's now their estimates in estimating the parameters of the model. Now, you could, if you estimate again, because it's finished at iteration, it'll just tell you no changes were applicable. So you could basically close this window, just cancel it. All right, let's suppose we save this as, just for the sake of argument, why don't we call it, it'll be just optimal correlations. But we haven't done anything else. We just optimized the correlations of our models that we had in PTF. and each one was called good. Okay, now what does this switch between simultaneous and independent modeling? This is sort of downward, it's like a spade or fork, okay? If you go and look at the downward arrow to see the three operates, simultaneous modeling, what does that mean? Okay, well, let's see. Let's suppose you want to test, let's go to, say, segment 1. Okay, we're in segment 1. Let's suppose you want to test whether there's a new trend between development year 8 and 9. Now, at the moment, this downward fork is this blue. It stands for simultaneous modeling. If I add a parameter between 8 and 9 to segment 1, it'll be propagated in every segment. Can you see? You're doing adding the same parameter in every segment. If I undo it, I undo it in every segment. Okay? So, if you're going to test for a trend change, we'll find this later on, for a trend change, a level change, and so on, if you're going to do it to one particular data set, you actually should do it to any other data set that belongs to the same cluster. Okay? Now, if all the process correlations, in other words, there's only one cluster amongst this, say in this case, 10 segments, then you should propagate that that particular action. And I'll explain that more in a subsequent video why you need to do that. Now, if all the correlations were in fact 0, in other words, each segment was its own cluster, there's no need to propagate that action. In other words, if you want to test whether a trend change occurs in a particular segment or level change, you don't have to test it in any other segments because, after all, they're not correlated. Okay. So, downward arrow, if you choose independent modeling, if I now go to segment 1, say, and add a calendar year parameter between 88 and 89, say, that will not be propagated. And that's the kind of thing you probably want to do if all the correlations are in fact 0. Now, I guess the best thing to do is only propagate it within a cluster. So now again with the downward arrow, and you go to simultaneous modeling clusters. Now, what are our clusters? Let's just look at our clusters. So we go back to the OC button. Well, one thing we could do is, why don't we go back to, say, independent modeling. Sorry for that interruption. Why don't we just make sure that we're on the same page? Why don't we load model optimal correlations, forecast, dialog box, just click on OK, go to forecast summary, and then you'll see that there's a tab under aggregate called clusters. So now, for instance, cluster 4 consists of seg, 5, 7, and 8. Now, tile vertically again. Why don't we get rid of the model display, say, and the forecast table. So we'll close those. So we're only looking at the residual graph, and we've got a table of our 5 clusters. Now, with the downward arrow switch between simultaneous and independent modeling, let's go there, go to the downward arrow, and simultaneous modeling clusters. So the argument is, which we'll show in a subsequent video, is that if you add a parameter to a particular data set, you should be also, to do the testing properly of that change in trend, you should also add it to any other data set that is significantly correlated with it. In other words, one that belongs essentially to the same cluster. So now, if I go to, say, seg5, there it is, and I add a parameter from, say, let's just make it between the last 2 years because it will be easier to observe in the residual display. So I go to 93 to 94 and add a parameter. If you do that, that should be propagated in seg7. So let's go to seg7 and seg8, but it's not going to appear, for instance, in seg3. Are we doing versus development years or calendar years? So all of a sudden it's changed to development years for some reason. I thought we were looking at things we're doing calendar years. So let's go back to seg5. Yeah, it's the calendar years. Seg4, it shouldn't be there. Seg3, it shouldn't be there, and so on. Seg10, it shouldn't be there. Okay, so this is usually what really should be active when you're trying to test for another parameter. Let me tell you, it's not that often that you actually test for another parameter in MPTF. I mean, the models you've designed in PTF are usually the good models. You know, they're the optimal models. You know, the amount of testing you might do in PTF usually would be very, very little. Okay, now if we go back and open the, well, let's close the forecast summary table and open the model displays. Now you can see now that, let's close the residual graph. You can see now that each one has the same trend structure, which might be common for segments. This is not common for lines of business, as you'll see later. Now, you know, some of these parameters across the data sets might be very much the same. Because we've clicked the new residual graph, all these optimization buttons have been grayed out because we haven't estimated the new model. But you know, whatever we did, we undid it, I think, or I can't remember. Maybe we didn't. We did add calendar year parameters to seg5. Okay, so just to make sure again we're on the same page, I'd like you to load the model again. Load model in new window. No, not in new window. Sorry, just load the model. Optimal correlations. And now, when you come to choice of optimization, if you go to the options button first and you go to modeling preferences, and let's just make sure again that our options are the same. If you go to MPTF options, the maximum MPTF iterations typically set it at 30. Go to optimization, and you can see that the MPTF optimizations, you're going to add constraints between data sets. You're only going to add constraints between data sets within clusters. In other words, two data sets that belong to different clusters, you're not going to set their parameters to be the same. Optimization will also include alpha constraints, which we'll discuss, and also alpha difference constraints. Alpha constraints are very unusual, and we'll discuss in a subsequent study when they actually happen. So basically, when we do the optimization, we've got everything ticked, and OK, and just click on OK. So we are all, I guess, in terms of optimization, we're all going to be doing the same thing. If you were to click on double R by default, you would be optimizing parameters within each segment, like you would do in PTF. And then after doing that, you'll also check whether there are any parameters across data sets that are the same, but only within clusters. Now, why don't we actually do that? Okay, and it also sets some of the alphas to be the same for the different segments. Okay, so let's call that optimal including parameters. Oops, can't type that file. Okay, let me do it again. Optimal including inc cross dataset parameters. Okay, let me save it that way. All right. Now we want to check that in fact parameters have only been set to be the same within clusters. You might remember that seg5, I guess I forgot the clusters. Well, let's do it. Let's load downward arrow in new window, and let's run optimal including CDS again, cross dataset constraints parameters. So we're running the same model again, but this time we do a forecast. Okay, and we also look at the forecast summary, and then we look at clusters. There's the clusters tab. It's under aggregate, second level, clusters. And now let's tile vertically minimize other types, so we only have the forecast summary. Then with the right button of your mouse, go to model display with the right button of your mouse and say select. I don't know that we actually had to run a model in the new window, but anyway, let's select the first one. We've got the model display. Okay, so we can check now. So if you go to seg5, some of the parameters have been set the same, but only with seg7 and seg8. That parameter has been set the same. So, I mean, another way of actually finding out which parameters have been set to be the same, if we go to segment 8 and click on this red, you're told that it's only been set the same to be with seg5 and seg8, seg7. Well, seg8, seg7, seg5 are all in the same cluster. Okay, so we're just checking that. Now, we're going to do something a little bit fancier. We're going to create a seg5, seg7, and seg8 data set. So with the right button of your mouse, go to the triangle group tab, select segx10, and go to composite data sets tab, and then we can create a new composite data set. So with the right button of your mouse, click on new, and let's call it it's CDS seg 5, I think 7 and 8. If my memory serves me right. Okay. Now click on CDS seg 5, 7, 8. And let me maximize this window. And we've got to select, let me move this window up a bit. And we've got to select seg 5, 7, 8. Let's select that as 3. bring them up, drop them onto the composite. Okay, just wait for you to make sure that you've done the right thing. Lagging is a little bit tricky. You actually have to highlight, when you highlight, the data set, make sure you grab it here. Okay, now go to models, and you'll find that you've got 3 related models. You won't have any composite. If you click on composite button here, you won't, but you've got the related models. So click on related, go to good, and with the right button of your mouse, click on open. So now go to OC. Well, these process correlations would be the same as if you didn't optimize the parameters. So it would be the same as running optimal 1. Let's just check that. So now, with the right button of your mouse on load model, we've got 2 runs of our composite data set. So let's get rid of one of it. So select the second run. Sorry. Just go to the residual graph. Select, or the model display, any display. Select the second run. And now close it. But is that, well, I've got to be careful. That's the one where we optimized in the second run. We didn't optimize in the first run. Okay, it's a bit tricky, so I forgot a little bit. So to find out what in the hell's going on, click with the right button on the logbook and select all. And for instance, for run 2, it's optimal. The model that we saved is optimal, including CDS parameters. For seg578, we're not that interested in, and for run 1, it's the same model. The one that we saved was optimal, including CDS parameters. Okay, well in that case, we can close either run 1 or run 2 of the composite data set. So let's go again to logbook, choose run 2, or any other display, and then click on the X. Okay, so now with the right mouse button, load model, select the composite dataset, composite dataset, and now load the model optimal only correlations. I'll wait for you. So we basically now are comparing 2 models. Actually, they're the same models in terms of that smaller cluster. So now just minimize other data sets. So let's see. On my right, I've just got the segment 578 where I just ran good. On the left, I've got all my segments, but let's highlight it, make it active, open OC, the cluster 578, that's the cluster 578 here. Those correlations, if I close that, would be the same as if I now make seg 8, 7, and 5 active and look at OC, and the correlations are the same. And one is just a subset of the other. If I now click with the right button on the double O, and I'm going to optimize both, then if we now, the seg 8, seg 7, seg 5 should give us the same model as seg 8 here. You can see it's the same parameter estimates. If we click on seg 5 on the left, it's the same as seg 5 on the right. In fact, why don't we do the forecasting for each? Forecast, all. But for the seg 10, we'll remove, well, I'm going to do Control A. Oops, I mean with a Shift key, everything. And let's remove everything except for 7, 8, and 5. So I only want to forecast the aggregate of 5, 7, and 8 in the larger composite dataset. So now I click on remove. If I'm going too fast, you can pause the video, okay, or go backwards a little bit. Remove, rewind, click on, let's save it. Only 5, 7, 8. Save. Okay. Now for the other data set, which only comprises 8, 7, and 5, you just click on OK. Now with the right button on the forecast summaries, all, and now tile vertically, minimize other types. Well, the table should be identical. Okay? All right. I want you to close 5, 7, and 8, so make it active, and close that MPTF one with the X. No, sorry, the one we want to, yeah, that's the one we want to close. CDS, SEG 5, 7, and 8. Make that active, click on the X. The model has been changed. Do you want to save? No. Okay. Now, I'd like you to go, so the model, okay, so what I'd like to do now is instead of running optimal correlations, let's load the model optimal including CDS parameters. Okay. Let's run that. And now let's simulate from that model. We're going to simulate a composite data set. Okay. Test. Simulate composite. We're only going to simulate one composite. So what it's going to do is, it's going to, this will be the trend structures and the process variance for each segment. But it's also going to simulate using these process correlations. So if you scroll to the right, these are the process correlations. Okay? So we're going to simulate only one composite data set. So for each triangle group, it'll simulate a triangle. Then it'll create the composite in the composite TG. So if you go back to the triangle group with the right mouse button on the triangle group tab, SEGX10, you'll see that there's a composite simulator triangle. If you now click on composite data sets, I'll maximize this, you'll see that composite DSSIM, these are the simulated triangles, one for each segment. If you go to the triangle groups and say open triangle group, say SEG1, basic triangle group, you'll see there's a simulated triangle called PLI Sim1. To close all basic triangle groups, you go with the X and the downward arrow. Close all basic triangle groups. Now, in the composite triangle group, go back to the Models tab, click on Composite DS, go to now Composite. So on the right pane, you have Models. If it's related, that's highlighted, click on Composite. And I want you to copy or drag and drop optimal, including cross data sets parameters. I mean, that's the way I called it. You might have labeled it slightly different. Drop it on top of DSI Sim. Now run it. And now tile vertically, minimize other types. So one is simulated. Of course, your simulation will not be identical to mine. And the other one is, we've got to go to seg1. No wonder they look different. So we've got to have seg1 on each side. Okay? And you'll see as you go to seg2, seg3, parameters will be the same. Let's do a forecast for each, all. But now you want to add all. You want to use all triangles, all data sets. OK. And this one, you just OK in the simulated one. Now I've got to forecast summaries, all, tile vertically, minimize other types, and statistically the mean reserves should be comparable. Okay, which they are. Alright, risk capital allocation, well, let's look at summary by data sets. Risk capital allocation, summary by data sets on the right. Risk capital allocation, it should be very similar. Statistically, they should be about the same. Of course, there's going to be some variation due to sampling variation. Now, if for each data set, with the right button on model templates, right button of your mouse, so if we're going to do this for the simulated composite and the original data composite, click on all, and just choose the SGI. So choosing the SGI model, single gamma, one parameter in each direction, development year, accident year, and calendar year for each data set within the composite. And you do the same for the others. Now open the residuals for each. And now let's compare them. Tile vertically, minimize other types, and start with segment 1 on each side. And then go to segment 2. And then go to segment 3. And you'll see strong similarities between the simulated and, well, the real data actually, which I simulated myself anyway. Okay, thank you.